रेजिस्टर्स। तो पिछले कुछ वीडियोस में हमने देखा कि रेजिस्टर्स क्या होते हैं, कैसे काम करते हैं। लेट्स टेक अ स्टेप फर्दर। तो कोई भी मटेरियल का या कोई भी रेजिस्टर्स का तीन फैक्टर्स पर डिपेंड करता है उसका रेजिस्टेंस। पहला हो गया लेंथ ऑफ वायर, लेंथ यानी कि कितनी देर तक उसमें करंट घूमने वाला है, कितना डिस्टेंस तक। दूसरा क्रॉस सेक्शन, और तीसरा रेजिस्टिविटी। रेजिस्टिविटी यानी कि दिस इज़ अ प्रॉपर्टी ऑफ द मटेरियल इटसेल्फ। डिपेंडिंग ऑन द मटेरियल, अलग अलग मटेरियल्स की रेजिस्टिविटी यानी कि अलग अलग मटेरियल का करंट कंडक्ट करने की एबिलिटी अलग अलग रहेगी। लेंथ ऑफ वायर तो काफ़ी सिंपल है अंडरस्टैंड करना कि अगर वायर लंबा है मतलब इलेक्ट्रॉन ज़्यादा देर तक पास होना पड़ेगा और ज़्यादा रेजिस्टेंस आएगा। क्रॉस सेक्शन इसलिए कि अगर ये एक वायर है, ये इसका क्रॉस सेक्शन है, तो एरिया ऑफ क्रॉस सेक्शन यानी कि ये जो सर्कल हो गया डायमीटर बेसिकली, तो जितना कम जगह रहेगी इलेक्ट्रॉन पास होने के लिए उतना ज़्यादा मुश्किल होगी। जितना ज़्यादा जगह रहेगी, जितना ज़्यादा क्रॉस सेक्शन रहेगा, इलेक्ट्रॉन्स ईजीली पास हो सकेंगे। सो उसका रेजिस्टेंस कम आएगा, और अगर थिकनेस कम होगी तो रेजिस्टेंस ज़्यादा आएगा। सो दिस इज़ इन्वर्सली प्रोपोर्शनल, दिस इज़ डायरेक्टली प्रोपोर्शनल, एंड दिस इज़ directly proportional. So that's what, so we can write it as directly proportional to the length, inversely proportional to the area, and agar if we take it's directly proportional to L by A, so make it an equation. There is a constant, so constant is rho. So it's not a P, it's a rho, it's a Greek symbol. ना देखते हैं कि रो क्या है। रो इज़ बेसिकली रेजिस्टिविटी ऑफ द मटेरियल, यानी कि उसके अंदर एबिलिटी कितनी है करंट पास करने की। अगर रो ज़्यादा होगा तो रेजिस्टेंस ज़्यादा होगा, अगर रो काफ़ी कम होगा तो रेजिस्टेंस काफ़ी कम होगा। सो फॉर एग्जांपल राइटली मेटल्स की रेजिस्टिविटी इज़ इन द रेंज ऑफ 10⁻⁻6 to 10⁻8। तो रेजिस्टिविटी काफ़ी कम होती है, तो उनका रेजिस्टेंस भी कम होगा। वेराज थिंग्स लाइक इंसुलेटर्स जैसे रबर एट्सेट्रा, उनका रेजिस्टिविटी 10⁻12 to 10⁻13, 14 इस टाइप से होगी। तो उसका मतलब उनकी रेजिस्टिविटी बहुत ज़्यादा है, मतलब रेजिस्टेंस भी बहुत ज़्यादा आएगा। सो डिपेंडिंग ऑन द रेजिस्टिविटी we choose the material that we need to choose the material that we need in a particular electrical application. So this was some factors the resistance varies on. Now let's look at resistances in series and parallel. It's one of the favorite problem to give in exams and etc. So let's look at a small circuit that we make here. We have a battery, we have two resistances here. Okay, now the battery is of, say for example, 100 volts, and resistances are of 5000 ohm each. There is 10 milliampere current flowing through it. Okay, now let's look at this circuit. Now we know that if 10 milliampere is flowing through this, 10 milliampere will flow through this, and the same 10 milliampere will flow through this entire circuit, and the overall circuit is powered by a 100 volt battery. So now let's try to find out the voltage across these 2 points. Okay, now we are trying to find out a voltage. So we have like a voltmeter here. Now we know that V is equals to IR. So here V, what is the I? 10 milliampere into resistance 5000. So total 50 volt. So we know that there is 50 volt around this, and we know that there will be around 50 volt across this, right? So it turns out that what happens is when we are flowing current through a circuit where resistances are in parallel and voltages, so the voltage gets divided between each of the resistors. So always remember this will be very useful in future when you're solving problems, when you're trying to understand electricity, how electricity works. When resistors are in series, voltage gets divided between resistors. Now I need to find out resistance between these 2 points. So what do I do is I know that the voltage it's getting divided, so basically overall voltage is 100 volt, and then there is, imagine V1 across this point plus V2 across this point. So whatever voltage gets divided across some points, it will get added, and V is equal to V1 plus V2. I know that V is equals to IR from Ohm's law. So what I'll do is I'll write IR is equals to IR1 plus IR2. I can cancel I from the equation, and I'll have R is equals to R1 plus R2. So now I know that when voltages, when resistance are in series, we can directly just add them to find the total resistance across those 2 points. Now similarly, imagine another circuit where I have this thing, 2 resistance in parallel. So I have R1 and I have R2. Okay, sorry, I have this and this, and I have voltage V here, I have current I going through here. Now how current flows is, when there are 2 different resistors, there is a different amount of current that will flow here, different amount of current that will flow here, I1 and I2. Now I know that I is equals to I1 plus I2. Now from Ohm's law we know that V equals to IR, so I will be equal to V by R. So what will happen is V by R equals to V by R1 plus V by R2. So when resistance are in parallel, here let's take it in series, we can cancel V from this equation. Basically we're taking V common here and then cancelling it. 1 by Rp equals to 1 by R1 plus 1 by R2. So always remember, when resistance are in parallel, this relationship is like this: 1 by Rp equals to 1 by R1 plus 1 by R2. Now let's see some practical examples. So I'll just make up a circuit here. I have, for example, say 8 ohm here, 8 ohm here, I have 4 ohms here, and then I have another 8 ohms here. Okay, now this is a circuit. I don't need to draw like a battery and current every time. Now I want to find out resistance between these points. So this is point A, this is point B. For simplification, what you can do is you can like name other points here. So this is P, this is Q, this is R. Okay, essentially it's the same thing. Anyways, so now I want to find out resistance between R, P, Q, resistance between point P and Q. So I know that there are 2 this thing, 8 ohm resistance in parallel. So RPQ will be 1 by RPQ equals to 1 by 8 plus 1 by 8. What we get is, we take 8 common, we do 1 plus 1, that's 2 by 8, that is 1 by 4 equals to 1 by RPQ. So I get RPQ equals to 4. Now I know that this much is, this is just 4, so RPQ is 4. Okay, so I've got this, that this is 4 ohm. Now I know that this is 4, this is 4, so when I am trying to find out RPR, so RPR will be between these 2 points, it will be 4 plus 4, so it will be 8. So now I know that across point P and R the resistance is 8. Now I need to calculate RAB. So I have one 8 ohm resistance here, another 8 ohm resistance here, and when 2 8 ohm resistance in parallel, we've calculated that here. We know that the equivalent resistance is 4. So we'll get RAB as 4. So this is just one simple calculation. You can get multiple kinds of circuits. So for example, if I have this, that I have 3 here, I have 3 here, 3 here, I have another 3 here, then I have some 3 in parallel, then I have 6 here, and say 4 here. How do I calculate? First I calculate these parallels, then this parallel, and then I add them all three because they are in series. So 3 resistance in parallel will be 1 by 3 plus 1 by 3 plus 1 by 3, 1 by R1 I can assume, so it will be 3 by 3 equals to 1. So my R1 will be 1. So this entire section is 1, this is 3, and then this will be 1 by 6 plus 1 by 4, that's 6 into 4, 24, cross multiplication. So multiply this and multiply this, 4 plus multiply this, 6 plus 4, 10 by 24. This is 1 by R3. So I know that, that's why I know this R3 here is 24 by 10. I can also call it 2.4. So this is 2.4. Now I do 2.4 plus 3 plus 1. 3 plus 1, 4. 4 plus 2.4 is 6.4. So my overall resistance across this point and this point is 6.4. So practice this a little bit more, so you'll get a better understanding and better idea how this works. So this is it. If you have any resistance problem, if you come across any interesting one, please let me know in the comment or anywhere else, and I'll be happy to solve them here. Thank you. If you like this video, please give a thumbs up, like the video, and please subscribe to the channel, share it with your friends. Let me know. Every view and every subscriber means a lot to me. Thank you.